Okay, so oftentimes we are told that a point is on a line. In a problem, it might say something like the point 1, 3 has a slope of 5, write the equation of the line. So we're just being told that the point is on the line. But if we had an example like 2, 4, the point 2, 4, and it lies on the line y equals 5x minus 6, how could we actually prove that this is true? Well, we can solve it two ways. We can prove that it is on the line in two different ways. We can actually solve it algebraically, or we could solve it graphically and prove that the point 2, 4 is on the line y equals 5x minus 6. How we could prove that it's on the line algebraically is by realizing that our x is 2 and our y is 4, and then substituting it into this equation here, y equals 5x minus 6. So our y is 4, our x is 2 minus 6. And then we just continue to rewrite the equation down, and we get 4 equals 4. Because 4 does equal 4, we are proving that the point 2, 4 is on the original line. Okay? Let's show another example, and we're going to do it both ways. The question says, is the point 4, 1 on the line negative 1x plus y equals negative 3? First of all, we're going to show this algebraically. Now, when we're proving that it is on the line or it is not on the line, algebraically, we actually do not need to get our equation into function form. We could write it down just as it is. We could take our x and our y, and we could substitute in. So here my x is 4, so I'm going to write negative 1 times 4 plus 1, which is my y, equals negative 3. And then we simply simplify. So negative 4 plus 1 equals negative 3. And so negative 3 equals negative 3. That is true. Because it is true, the point 4, 1 is on the line. It's on the line negative 1x plus y equals negative 3. Now, could you prove this another way? Could you prove this graphically? You could. You would first need to put your equation into function form. So if I solve for y by moving my x over, I would get y equals x minus 3. That has a slope of 1 over 1 and a b of negative 3. If I were to graph that, just like what we've been doing, I would go down to 3, and then I would go up 1 over 1, up 1 over 1, up 1 over 1, right? And then I would go down 1 over, oh, let's go back here. Not that. Down 1 over 1, there we go. Over 1, down 1 over 1, down 1 over 1. And that would be the line that they gave us here, y equals x minus 3. Is the point 4, 1, here it is, 4, 1, there, right there, that's the point 4, 1. Is that point on this line? Yes, it is. So we could solve it with a graph, or we could solve it algebraically. Let's do one more just to make sure you're understanding. Is the point 3, negative 2 on the line 2x plus y equals 1? Okay, so first we're going to solve this algebraically. Again, this is really the only time where it is not necessary to put it in function form because you're just substituting in your x and your y value. So you don't need to get it in function form ahead of time. You could, but it's not necessary to do so. Plus a negative 2 equals 1. I'm just substituting in. My 3 is here, so my 3 goes here. My y is negative 2, so my y is negative 2. And then I just simplify. So 6 minus 2 equals 1. And then I keep simplifying. 4 equals 1. That is not true. That is not true, which means the point 3, negative 2 does not lie on the line. Now it does lie on an infinite number of lines, but this is not one of them. Okay? If we wanted to prove this graphically, again, we would subtract 2x over. We would get y equals negative 2x plus 1. My slope here would be negative 2 over 1, and my b would be 1. So I would go up to 1, and then I'd go up 2 over 1 in the negative direction because my slope is negative, down 2 over 1, down 2 over 1. Then I'd find the point 3, negative 2. The point 3, negative 2 is right here. That does not lie on this line here. Ooh, it's not a very good line. But see how it's not on the line? So we can prove it algebraically. No, it's not on the line. Or we could prove it graphically. No, it is not on the line. There you go. Try it on your own now. Bye.